My background, well, it's a little bit atypical because I've got a first master degree in natural sciences in 2005. And then I've been working in the field of preclinical medical research for 15 years. When I've got my second master degree, that is in data science and scientific computing. And since then, I've been employed in CERIC-ERIC as a data scientist and software engineer. My contribution to PaNOSC revolves around Work Package 4 data analysis. My aim is to give researchers some web tools that runs on federated resources mostly, making it possible for them to work remotely during the COVID pandemic and also later, of course, to share their result and observation and improve repeatability of their experiment, lowering the effort required to align with FAIR principles. H5nuvola is a project that was born from an idea of George Corosius from Elettra and was developed by CERIC-ERIC under the PaNOSC project. It is a free and open source tool to explore HDF5 files that are a standard format to store multidimensional scientific data, along with their metadata in self-describing hierarchical structures that resembles folders and files mostly. Yes, I think that H5nuvola will push a FAIR principle in a researcher's job by providing a repeatable and trackable way to analyze and share their data through the use of the H5nuvola applications. Those applications can be divided in two categories. There are some general purpose applications developed to overview basically any generic one or two-dimensional dataset. And under this category in future, we will also develop viewers for 3D datasets. And then there are custom applications for special cases. Sure, let me share my screen. Here you see a typical run of H5nuvola on local data. You choose an HDF5 file, then you choose a dataset. You can browse the file or just search for it very quickly. And then plot is quickly displayed. There are different options for the visualization that the user can customize. And some analytics are embedded, so one can zoom data or select a portion of the files and receive statistics on it. User can zoom, in this case a one-dimensional series, and basically do any kind of visualization that you can do in Plotly. If we select, for example, a two-dimensional dataset, you can see that it is quickly shown, and you have the same kind of analytics. So you can, for example, select a region and receive some basic statistics. In this case, the region can also have other shapes, so it can be drawn freeform. And you can also draw a line, and you receive the section in that of the array in that point. So this is a basic quick overview of the H5nuvola potential. So first I mentioned custom application. I will describe them a little bit before showing you. So those are specialized not only to view, but also to remotely process datasets and to run pipelines on particular experimental datasets. So at the moment, a single custom application has been required to explore X-ray fluorescence experiment, and especially PyMCI output. And it's called XRF-FitVis, that was already prototyped as a Streamlit web application under the PaNOSC project. So now let me show you a demo. So here you can see data stored on Elettra Virtual Unified Office, or VUO. We have a link to H5nuvola, and it will directly open, in this case, the file that you chose. You can also change the file later. You can select a region of the image, and you see all the elements that are included in the spectrometry. And here we have an image calculator. That is a tool where you can add, subtract, make operation on the array of the datasets as they were NumPy variables. So if you write a legit formula, for example, here I'm showing the ratio between aluminum and sodium in this scan with a simple analysis online, real time, without any kind of issue. And of course, you can see the value pixel by pixel. You can also choose a single data set. In the same efficient way as before. So here we have two different visualizations. One is the single data set in 2 dimensions, and the other one is a 3-dimensional plot that was required by the researcher. Here you still have the histogram of the values as before, but also you can write some, for example, interpolation, or you can explore the data by moving around your plot and choosing your best image, and also change the color map. If you have a little bit of fantasy, there are tens of color maps. In the changing the contrast, you can highlight details in some region of your image. This is basically just a showcase of what can be done with PaNOSC under H5nuvola. Well, I know that scientists are usually negatively disposed against writing web applications, especially interactive ones. So writing code for file access, callback, controls, etc. can require really a lot of knowledge and time, of course. So I wrote H5nuvola with a specific aim of enabling user to write and share this application. So the framework itself manages data access, callback, are easy as just using a Python decorator. So thanks to Dash that empowers H5nuvola. Dash is the framework that was chosen to design this kind of web application. So the HTML resides just in an empty template and contains just the general layout of the page. And some templates are already available for the apps that you have just seen. The Dash application controls what is shown inside the different areas of this layout and how different parts interact with each other with just a simple Python code. So in the current application, all the data visualization is done with Plotly, that is born to run with Dash. But any kind of information can theoretically be displayed using Matplotlib, Seaborn, and other data visualization libraries. To access data, that is one of the big issues, H5nuvola used the H5 API library to open HDF5 files. But data sources is an abstract class contained in the framework that can be inherited to link H5nuvola to basically any kind of data repository. So implementing its interface, even an API-based data structure can be attached, and its content can be displayed among H5nuvola other data sources. That also multiple data sources can be used at the same time. So as it is, it already can show data in local folders or network folders and subfolders, and data present in the online storage of Virtual Unified Office from CERIC. And the session data are stored in the server. So a user that is coming back to H5nuvola will find the last visualization of the last file he was working on. And this can help also in saving your job in case of a blackout, let's say. Well, yes. So as you can see, H5nuvola lays at the border between data visualization and data analytics. So in principle, an application, an H5nuvola application, could synchronously run different pipelines or interact with databases, trigger action, or do any other function. And there are a lot of functionalities that I plan to add. So better logging for sure, user-friendly user manual. So that is written not only for the developers, but also for researchers to enable them to write their own code and to move the script into functional web application. So a large improvement for sure will include the access to federated resources and catalogs when available, and authentication, maybe federated authentication, and identity management capabilities. Tell me, what would you like to see as an application? How do you want your experience to be? Tell me, what do you want to see in H5nuvola? So help me designing what you will use in the future.